Let us begin. So on yesterday, we started looking at other ways to analyze a polynomial function. We did domain, range, and behavior, but we also added x-intercepts, increasing and decreasing intervals, and relative maxima and minima. So first example we did was given one graph, looked at how to find all 6 parts. So do expect that probably one of your questions on your quiz this weekend will give you a graph, find all 6 parts. And then example 2, use a table of graph values to graph, produce the table, found end behavior, found zeros, and found the max and the min. So now that we have those pretty much situated, we're going to do 2 more examples. One in which we're going to use the table again, and then another where they give us the information, we have to produce the graph. So it's a little bit different. So after examples 3 and 4, we'll transition into factoring. So let's start with example number 3. We've got f of x equals x to the 4th minus x to the 3rd minus 20x squared. So the first thing we're going to do is go right to the calculator. Excuse me. Again, if you don't have a graphing calculator, A, get one, or B, download the one to your Chromebook using the link that I provided for you. I'll make sure to provide that link again if you need the link again. But you do need a graphing calculator. Make your life a little bit easier. So go to y equals, type in the function, so x to the 4th power minus x to the 3rd power minus 20x squared. Remember the exponent key is right above the division sign. So the first thing we'll do is take a look at the graph just to see what we should be looking at here. So notice that for this particular graph, part of it does come off of the page, but you can reasonably tell what it's going to do. It's going to go down, curve back up, curve back down, and then curve back up. So it's going to take the shape of a W. So it's going to take the shape of a W when you go ahead and actually graph it yourself. Now we look at the table, find some points to plot. So on your table, you might have to use your arrow keys to move up or down so you can see what kind of numbers you're looking with. So I can see I can definitely plot -5, 0, 0, 0, -4, 0. Doesn't look like anything else looks all that nice to plot though. So I at least have 3 points that I can put on this graph. Now, for those of you who don't have a graphing calculator, the only other way that you'd be able to do these graphs is to start plugging in numbers and graph it the long way. Yes, you could use websites like Desmos and things of that nature to also graph it, but you still have to be able to produce the graph, sketch the graph, and find the information associated with it. So if that's the route you choose to take, that's on you. But at least this way, worst comes to worst, if the internet goes out, you still have a graphing calculator. So from the table, points of the plot, -4, 0, 0, 0, 5, 0. 1, 2, 3, 4. 0, 0, 1, 2, 3, 4, 5. And then we need to make that W-shaped graph. So there's your sketch of your graph. Any questions so far? All right, so let's go ahead and find the other things they asked for. End behavior, location of the zeros, relative maxima or minima, based off of what we can tell from that graph. So end behavior, remember, is your, if x goes to negative infinity, what is f of x doing? And if x goes to positive infinity, what is f of x doing? So what goes into two blanks? Right, you are. So direction of the two arrows helps you fill in those end behaviors. Great work. So zeros. So zeros, simply looking at the x-axis. Plus side is the table pretty much gave us those. -4, 0, 5. And then max and min. So max and min, we have a maximum value there. So we have a max value of 0, 0. So the minimum values in this case are undetermined based on sketch of the graph. So here's why it's undetermined. The only reason these are stopped right there is because that's how much graph we had. If you look back at your graph on the calculator, this graph is going down. We don't know where it eventually turns back around. We could always guess, but based off of this graph, we don't know where that point is. We don't know where that point is. So we're only going based off of what's on the sketch. We're only going based off of what's on the sketch. Now, the problems that you will see in your homework, on your quiz, on your tests, on your final, They'll be graphs in which you can clearly see a minimum and a maximum. So your problem will clearly have a minimum and a maximum. Other than that, that's it for example 3. Questions, example 3. Not seeing any in the chat, not hearing any. So we're good to go to example 4. So, example 4. Sketch the graph of the polynomial function with the following characteristics. An even function with a minimum at x equals 3, zeros at -4, -1, 2, and 5, and a positive leading coefficient. So this time they didn't give you a function. Rather, they gave you the characteristics, and they want you to give a sketch of the graph. So a sketch is not the same thing as an exact rendering. If they wanted an exact rendering, they would have given you a function. So in this case, we're giving you a sketch that includes all of these characteristics. So here's the true test of, do you know what these things mean? So we're going to go through each of them and then produce the sketch of the graph. So an even function. So an even function is a function in which either both ends of the graph are pointing up, or both ends of the graph are pointing down. That's an even function. Either both ends of the graph are pointing up, or both ends are pointing down. How do you know which one is which? It depends on the leading coefficient. So if the leading coefficient is positive, that's the graph. That's how the graph would look. If the leading coefficient is negative, that's how the graph would look. So those are for even functions. An even function is something like x squared, x to the 4, x to the 6. Something raised to those exponents. An odd function would be something in which, so this is an example of an odd function, and that's an example of an odd function. One part's pointing up, one part's pointing down. Again, the leading coefficient would tell you which one you're using. If the leading coefficient is positive, that's the way it would look. If the leading coefficient is negative, that's how it would look. So since we want an even function, it's going to look like one of these two types. Any questions before we continue? So that's what that means. We don't have enough to do a sketch yet, but that's what that part means. Minimum at x equals 3. So minimum at x equals 3 means you need a low point at 3 comma something. So what that something is, that's up to you. Put that point wherever you want so that it's a low point. So that means I go to where x is equal to 3. And I put a minimum. So I'm going to put it right there. Why did I choose there? Don't like it. I just need it to be a low point. I need it to be a minimum. Zeros at -4, -1, 2, and 5. So remember, zeros are x-intercepts. Zeros are x-intercepts. That means at -4, -1, 2, and 5, I should have points. And a positive leading coefficient. Positive leading coefficient is going to tell me what direction my arrow should be pointing. The positive leading coefficient means I now know that this is the shape my graph should be taking. So when I draw my graph, there's my sketch. So let me try to answer some of the questions that I think might be out there, and then you all can have at it with questions. So how do I know that my sketch is right? You know that your sketch is right if you satisfy all the criteria. So as long as all of the characteristics are satisfied, then your sketch is correct. So, even function. Are both my arrows pointing up? Yes. Minimum at x equals 3. Here's the point. Here's my point at x equals 3. Sure enough, it's one of my minimum points. Zeros at -4, -1, 2, and 5. That means when I go to the x-axis, I better have points at -4, -1, 2, and 5. Positive leading coefficient means both arrows should be pointing up. So it's an even function with a positive leading coefficient. So that's how the arrow should be pointing up. So my sketch is now. Is it the only sketch that exists? No. That means that Elena's sketch could be different than Christian's sketch. Christian's sketch could be different than Jane's sketch. Jane's sketch could be different from Josh's sketch. Josh's sketch could be different from Joseph's sketch. So, if your sketch is different, that's fine. You just need to make sure that it satisfies the criteria. As long as the characteristics are met, you're good to go. Any questions on example 4? So what that means is when you look at the answer key for the homework assignment that's due tomorrow, for problems 7, 8, 9, and 10, you're not going to have an answer there. It's going to say answers will vary. You need to make sure that you satisfy each of the characteristics. See your notes for descriptions of the characteristics. Other than that, any questions on graphing before we transition? Plus side of graphing is your graphing calculator does take care of a lot of it. Your graphing calculator does take care of a lot of this. So section 5.5. So now we're going to get into how we solve a polynomial function. How do we go about solving a polynomial function? So way back when we started the school year, one of the sections that we spent a couple of days on was going through all the different types of factoring. So yeah, greatest common factor, which goes for any type of factoring. Difference of two squares, sum of cubes, difference of cubes, MAF, and grouping. So those are the major types of factoring. We are not about to go through all the 6 types of factoring again, at least not in this setting, because we've already done that once. Rather, what I will do with this first page is, in a separate video, I will go through each of these types with the examples that are listed there, so that you get a review or a recap of all different types of factoring. We will be factoring a good chunk of the rest of this school year. So you need to know how to factor. If you are struggling with any type of factoring, for example, if you still struggle with difference of cubes, come see me during an asynchronous after hours session so that we can get that taken care of. But we are going to be factoring, and factoring pretty heavily in numerous parts of this second semester. So be prepared in advance. What I've also done to help you out as you get started. So this is a review sheet that I made a couple of years ago. Greatest common factor, trinomials, MAF, difference of two squares, grouping, sum of cubes, difference of cubes. So it's basically a handout of all the different types of factoring and how you go about doing it. So this handout I've already posted to Google Classroom for those of you who want to use it as a reference. You don't have to use it, it's there if you want to use it. Today our focus is going to be on solving polynomial equations, which is going to use factoring. So let me remind you briefly the steps for factoring, and then we just gonna get right on into it. Step 1, get the equation equal to 0. Get the equation equal to 0. That's first. Step 2, factor completely. Factor it completely. Step 3, set each factor equal to 0. And then solve each equation. Solve each equation. So when you are solving the equations, keep in mind square roots can and probably will show up. Quadratic formula can and probably will show up. Complex numbers, imaginary numbers can and probably will show up. So don't be fearful when they show up. Don't be afraid when they show up, because they probably will. So let's do a fairly simple one to get started. So if you started example 1, oops, I changed it in the first period, changing it now. So we have x to the 4th minus 4x squared minus 32 equals 0. Start off with something not too difficult. So I want you to pay attention to the 4. So that 4, the biggest exponent is 4. So remember, the biggest exponent has a special name to it. It's called the degree. So when you are solving an equation, the biggest exponent, also known as the degree, tells you how many answers you should have. That's how many answers you should have in this problem. Case in point, you are not done with the problem until you have 4 answers. So just know that in advance. Keep that in the back of your head. So, example 1, the equation is already equal to 0. So we go ahead and try to factor it. We look for the greatest common factor. X to the 4th minus 4x squared minus 32 equals 0. There is no greatest common factor because there's nothing that divides out of everything. Okay, keep going. You got 3 terms. This is an MAF problem. So we need 2 numbers that multiply to negative 32 and add to negative 4. What can I use? Don't be shy, we're going to wake those factoring brains up. So I like the 8, and I like the 4. So which one is negative? Be negative. Negative 8 times 4 is negative 32. Negative 8 plus 4, negative 4. So the leading coefficient is 1, but if I divide by 1, nothing changes. So you have x minus 8, x plus 4. X times x is x squared. You need x to the 4th. You need x to the 4th. So make those x squared times x squared. now it's factored. Any questions before we continue? So again, you have to get back to x to the fourth. You can't leave it as just x. That's not good enough. So now let's continue. It's already factored. We're going to get up into two parts. X squared minus 8 equals 0. So add 8 to both sides. So x equals plus or minus the square root of 8, which you can break down, plus or minus 2 square root of 2. Go to the other equation. Subtract 4 on both sides. X squared equals negative 4. So x equals plus or minus square root of negative 4, which is plus or minus 2i. Remember I said at the start of the problem, since your degree was 4, you needed 4 answers. There's your 4 answers. Plus or minus means x equals 2 square root of 2. X equals negative 2 square root of 2. There's 2 answers. X equals 2i. X equals negative 2i. There's your 2 answers. 1, 2, 3, 4 answers. There you go, problem's over. Any questions, example 1? So let me kind of warn you in advance. If you need to review factoring, you need to hurry up and do it very quickly. Plus side is the homework that's due on Friday. The first part of it requires you to review factoring, in addition to solving equations. All right, example 2. So we've got 8x to the 5th plus 10x to the 3rd equals 12x. Be mindful of the fact that the biggest exponent is 5. So that means you need 5 answers. You need 5 answers to this problem. So I need to try to solve this. So what do I need to do first? X to the 5th plus 10x to the 3rd minus 12x equals 0. So now let's start trying to factor it. So what can I do to this problem? How can we start factoring this? Find a GCF. So 8, 10, and 12. everything's divisible by 2, and I can take out an x. If you take out 2x, that's 4x to the 4th plus 5x squared minus 6 equals 0. So far, so good. We've got 3 terms. So it's MAF time. We need 2 numbers that multiply to negative 24 and add to a positive 5. What are we working with here? What numbers can we use? 3 is one. What kind of 3? Negative 3 will work. Paired up with negative 3. Since your leading coefficient is 4, we're going to be dividing by 4. So that gives us x squared minus 3/4 and x squared plus 2. Remember, x squared comes from the fact that we have to go back to x to the 4th. We can't just put x, we have to put x squared. And 3/4, we can't leave it that way. So our factored form is 2x parentheses 4x squared minus 3 parentheses x squared plus 2 equals 0. Any questions before we continue? Get rid of these steps here so I can give myself some room. All right, so each factor equal to 0. 2x equals 0, so that's easy enough. X equals 0. Four x squared minus 3 equals 0. So 4x squared equals 3. X equals 3 over 4. So x equals plus or minus the square root of 3 over 4. So x equals plus or minus the square root of 3 over 2. So it's fully simplified. X squared plus 2 equals 0. So x squared equals negative 2. Take the square root of both sides. Square root of negative 2 means plus or minus the square root of 2i. Check to make sure that you have 5 answers. So 1 plus or minus means 2, 3, plus or minus 4, 5. You have 5 answers. That's it. I'm good. Ain't that bad. Again, it's a lot. It's at first because it's going to force you, some of you all, to remember all those rules for factoring. Now, if you don't forgot them entirely, time to start a review and any questions before we do example 3? Example 3 is that's where we'll end up cycling. All right, example 3. I want to give myself some more room with this one. So example 3. X to the third power plus 27 equals 0. So, equation's already equal to 0. So that part's taken care of. There is no greatest common factor. You've got two terms. One of them raised to the third power. So let's bring in the sum of cubes. Let's bring in the sum of cubes. So sum of cubes, first thing, you have to figure out what to the third power will give you x cubed. That's x. And then what to the third power will give you 27. That's 3. So you got to break the problem down first. Sum of cubes has a formula for it. A plus b, a squared minus ab plus b squared. So remember, these have formulas. So the a part of the formula is for the x. The b part of the formula is for the 3. That's x plus 3. X squared minus 3x. 3 squared is 9. Factor. If you're looking to try to factor that, don't waste your time. Because you can't find two numbers that multiply to 9 and add to 3. Don't waste your time. Any questions before we continue? Now that it's factored, set each factor equal to 0. So x plus 3 equals 0. That's negative 3. So there's one answer. So x squared minus 3x plus 9 equals 0. So factor it, so if you can't factor it, there's one other way to solve out this problem. Let's welcome back quadratic formula. We were all in class together. This is when the oh my god and groaning would start. There's that formula again. If you can't factor something, you've got a way out. So don't put no solution. Get that problem all the way marked wrong. So A is equal to 1, B is equal to -3, and C is equal to 9. So the opposite of -3, plus or minus the square root. -3 squared minus 4 times 1 times 9, all divided by 2 times 1. Quadratic formula. You're not going to run from it. You're going to solve it. So the opposite of -3 is 3. -3 squared is 9. 4 times 1 times 9 is 36 over 2. 3 plus or minus square root of -27 over 2. That's 3 plus or minus 3 square root 3i over 2. And since, well, my highlighter, this 3, and that 2, those three numbers cannot simplify. So that means that is your final answer. That's your final answer. Check to make sure that you have the right number of answers. You're supposed to have 3. There's 1. Plus or minus means there's 2, there's 3. Problem's over. Anybody head hurt yet? It's okay if it does. Again, just remember, you play the game. You don't let the game play you. That's simple. Any questions on example 3 before we get ready to close up shop? 4, 5, and 6 we'll do on Thursday.